So, students, stage 3 existed approximately from the year 1960 to 2000. During this period, instead of operating each power station separately, engineers started connecting multiple generating stations, substation, and transmission networks together. This created a large interconnected power network, commonly known as the power grid. Students, remember one point. The main objective of this stage was to improve the reliability of the power system. Instead of depending on one generating station, several generating stations could now support each other. During the period 1960, electricity demand increased rapidly due to industrial growth, urbanization, and agricultural development. Different regions had different electricity demands. Some states generated excess electricity while others faced shortages. Operating every power station independently was no longer efficient. Therefore, utilities decided to connect generating stations through extra high voltage transmission lines. Now, students, what is the mean by extra high voltage or EHV? So, you have already learned this. Higher voltage reduces transmission losses. As the transmission distance increases, even higher voltage becomes necessary. Therefore, utilities started using transmission voltages such as 220 kV, then 400 kV, and later 765 kV. So, these high voltage transmission lines connected different cities, different states, and eventually different regions of the country. So, this formed a large interconnected transmission network. So, students, another important development during this stage was the introduction of SCADA. So, as you all know, the full form of SCADA. So, let me ask you one question. So, suppose there is a fault at a substation located 300 kilometers away. So, should the engineer travel to that location just to know whether the circuit breaker is on or off? Obviously not. So, instead, SCADA allows operators to monitor and control substation from a central control room. So, it collects information such as voltage, current, frequency, power flow, and equipment status in real time. In real time. So this display information is displayed on computer screens, allowing operators to take quick decisions. Now imagine you are using a CCTV camera in your house. So instead of physically visiting every room, you can monitor everything from one screen. Similarly, SCADA allows power engineers to monitor multiple substations from one control center. So this saves both time and manpower. Now we will discuss the characteristics of this interconnected grid system. So the first characteristics was the formation of interconnected national and regional grids. So instead of isolated power station, entire regions were connected. Then the second characteristics is the large transmission networks were developed. Large transmission network developed. So thousands of kilometers of transmission lines connected to different states. Then the third characteristic is the SCADA based monitoring. SCADA based monitoring. So this enabled remote monitoring and control of substation. Then the fourth characteristic was the load dispatch centers were established. Load dispatch center were established, and the fifth characteristic is the overall operation of the grid becomes centralized. We can say centralized grid operation. So allowing better coordination among different utilities. Now we will discuss the features of this interconnected grid system. So the first important feature was the power sharing. So suppose Maharashtra has surplus electricity while Gujarat is facing shortage. So through the interconnected grid, electricity can be transferred from Maharashtra to Gujarat. So this improves the overall utilization of generating stations. Then the second feature was improved system reliability. Improved system reliability. So if one generating station fails, another station immediately supplies electricity. Then the third feature was the better frequency control. Better frequency control. So the Indian power system operates at 50 Hz. So the frequency should remain very close to this value. Interconnected grid helps to maintain a stable frequency. Then the fourth feature was the increased system stability. System stability. So since multiple generating stations are work together, the entire system becomes more stable. Now we will. So the first advantage was the reduced generating reserve. Advantages. The first advantages was the reduced generation reserve. So earlier, every station had to keep additional generators ready as a backup. After interconnection, different power stations could support one another. So reducing the need for standby generation. Then the second advantage was higher reliability. Higher reliability. So consumers experience fewer interruption. Then the third advantages was improved power quality. Improved power quality. So voltage and frequency becomes more stable, and finally the generating stations were utilized more efficiently. That reduces the overall cost of electricity generation. Although this stage was an important improvement, but it still had several limitations. So the first limitation was limited automation. Limited automation. So many operations still required human intervention. Then the second limitation was manual outage restoration. Manual outage restoration. So if a fault occurred, operators had to identify the problem and restore supply manually. This process took time. Then the third limitation was aging infrastructure. Aging infrastructure. So many transmission lines, transformers, and substations becomes old, resulting in higher maintenance cost. Then another important limitation was transmission congestion. Transmission congestion. So when too much electricity flows through transmission line, then it becomes overloaded. So generally, this phenomenon known as the transmission congestion. And finally, the communication remained one way, or we can say that one way communication. So consumers simply consume electricity. So there was no two-way communication between consumers and utilities. So by the year 2000, utilities realized that the simply connecting power station was not enough. They wanted automatic monitoring, then faster fault detection, digital communication, computer-based control, and improved operational efficiency. So this led to the development of the digital power system, which we will be studying in the next stage. Back to the year 1950s and 1960s. So at that time, India did not have one national power grid. Instead, every state had its own electricity generation and transmission system. For example, Maharashtra had its own power system, then Gujarat had its own, Tamil Nadu had its own, Punjab had its own. Each state generated electricity only for its own consumers. Initially, this arrangement worked well because electricity demand was low. But as India started developing, many new industries were established. Cities expanded rapidly. Agriculture also becomes electrified. Farmers started using electric pumps for irrigation. As a result, the demand for electricity increased significantly. Now, another problem appeared, the problem of the natural resources. So, some states have abundant coal. Some have large rivers suitable for hydroelectric power. Some have very limited power resources. Because of this, some states generated more electricity than they required, while others suffered from power shortages. So, for this problem, the government of India and the Central Electricity Authority realized that operating each station independently was not the best solution. Instead, they decided to group neighboring states together. These groups become known as the regional grids. Each regional grids connected multiple states through high voltage transmission lines, allowing them to exchange electricity whenever required. So, we will discuss the objective behind this formation of regional grids. So, the first objective is the exchange of electricity. Exchange of electricity. The first objective was to exchange electricity among neighboring states. For example, so suppose Maharashtra generated excess electricity during the night. Instead of wasting it, it can supply electricity to Gujarat. Similarly, during peak demand, Gujarat can return electricity whenever required. So electricity become a shared resource. Then the second objective was to improve reliability. Improve reliability. Suppose one generating station suddenly trips due to a technical fault. If the state is connected to the neighboring states, electricity can immediately be imported. So this improves reliability and reduces the possibility of blackouts. Then the third objective is the better utilization of generating station. Better utilization of generating stations. So power plants are expensive to construct. So if one power plant remains idle while another is overloaded, so resources are wasted. So regional grids allow generating stations to be utilized more efficiently. Then the fourth objective, reduce electricity cost. Reduce electricity cost. So instead of constructing additional power plants in every state, states can share existing generation. So this reduces the overall cost of electricity generation. Then the fifth objective is to improve frequency and voltage control. Improve frequency and voltage control. So students, you already know that the Indian power system operates at 50 Hz. If one state suddenly experiences a heavy load, its frequency may decrease. When neighboring states are connected, they can support each other, maintaining both frequency and voltage within acceptable limits. Then the sixth objective is emergency support. Emergency support. So suppose a cyclone damages transmission lines in one state. Can neighboring states help? Yes. So through the regional grid, the electricity can be supplied from one state until normal operation is restored. Then the seventh objective is the planning large power plants. Planning large power plants. So students, very large thermal and hydroelectric power plants generate huge amount of electricity. So one state alone may not require all this power. So regional grids make it possible to distribute electricity efficiently among several states. Then moving to next part. Now we will see the formation of this regional grid. So the first regional grid was the first regional grid was the northern regional grid. So this region developed during the late 1960s and early 1970s. It includes Jammu Kashmir, Ladakh, Himachal Pradesh, Punjab, Haryana, Rajasthan, Uttar Pradesh, Delhi, and Chhattisgarh. Chhattisgarh. All these states uh, belong to this northern regional grid. So, since this region has many Himalayan rivers, hydroelectric power become one of its major energy resources. So, that examples can be Bhakra hydroelectric project, then Nagta Zakri, and several other hydroelectric stations. So thermal power stations such as Rihand also contribute significantly. Then the second uh, regional grid was the Western Regional Grid. Western Regional Grid. So this region includes the states like Maharashtra, Gujarat, Madhya Pradesh, Chhattisgarh, and Goa. So this region contains several major industrial cities. Therefore, the electricity demand of this region is very high. So in this region, important generating stations are the Korba Thermal Power Station, then Ukai Thermal Power Station, Tarapur Atomic Power Station, and Chandrapur Thermal Power Station. Then the third western region is the Southern Regional Grid. So the Southern Regional Grids include states like Andhra Pradesh, then Tamil Nadu, Karnataka, Kerala, Puducherry, and Telangana. So this regional grid remains electrically separated from the rest of the India until 2030. Then the next regional grid was the Eastern Regional Grid. Eastern Regional Grid. So the Eastern region mainly utilizes India's rich coal resources. So in this region, the states are West Bengal, Bihar, Odisha, Jharkhand, and Sikkim. And the last regional grid was the Northeastern Regional Grid. Northeastern Regional Grid. So the Northeastern Regional Grids include Assam, Meghalaya, Tripura, Manipur, Mizoram, Nagaland, and Arunachal Pradesh. So this region has abundant rivers, so making hydroelectric power an important energy resource. So students, so what was the final result of forming these regional grids? So initially the states were connected, later the regions were connected, and finally all the five regional grids were synchronized together. So this resulted in the national grid of India. So the final synchronization was completed in the year in the year 2000 in the year 2013. So when the southern grid was connected to the rest of the country. So this achievement is popularly known as the one nation, one grid, one frequency. So instead of every state operating independently, India developed regional grids where neighboring states shared electricity, supported one another during emergencies, reduced electricity cost, and improved reliability. So these regional grids later become the foundation of today's national grid.